Hello students, my name is Satam Singh. Students, today we will be learning how to find out the number of peroxy linkage present in a given structure. Yes, so we will be learning with what is the trick to find out the number of peroxy linkage present in a particular structure. So students, here what we have written if only one central atom is present. If only one central atom is present, what you will be doing? You will be finding out the average oxidation number. You will be subtracting it. You will be finding out average oxidation number. Then you will be finding out the maximum oxidation number. You will subtract this maximum oxidation number from the average oxidation number, and you will divide it with what? You will divide it by 2. So you will get the number of peroxy linkage present in that structure. Yes students, let us take the example over here. So what example we are taking? Again, the example which we are going to understand is what? It is chromium pentaoxide. Again students, when we say chromium pentaoxide, so you know it is going to be X. Here it is 5 into minus 2 is going to be 0. So X is going to be what? It is going to be plus 10. And what is this is which oxidation number? This is going to be your average oxidation number. And the maximum oxidation number of chromium is going to be what? It is going to be plus 6. So you will say, to find out the number of peroxy linkage in CrO5, that is chromium pentoxide, you will take average oxidation number, okay, and then there is maximum oxidation number. Maximum oxidation number is subtracted from average oxidation number, and you are going to divide it with what? 2. So what you will be getting? You will be getting some 4 by 2. So here the answer is going to be what? 2. So you know there are 2 peroxy linkage present in this. See, this is going to be your chromium pentaoxide. It is having which structure? It is having butterfly like structure, and it is containing how many peroxy linkage? It is containing 2 peroxy linkage. Even if you don't know the structure, you can find out the number of peroxy linkage by the formula average oxidation number minus maximum oxidation number, and then you will be dividing it with what? 2. You will be dividing it with 2. And what if there are 2 central atoms are present? If 2 central atoms are present, you will take the another example. It is going to be H2, S2, and here there is going to be O8. This is which acid? This is called Marshall's acid. Yes, it is called Marshall acid. It is peroxodisulfuric acid. So this is going to be our which acid? This is going to be Marshall's acid. Okay, that is going to be peroxo. Yes, you write it as what? You write it as peroxodisulfuric acid. So I am writing it as peroxodisulfuric acid. Yes, it is going to be peroxodisulfuric acid. So students, what we will be saying, we will try to find out. See, this is 2 into plus 1. For H we will write plus 1. Here for sulfur we are finding out there are 2 central atoms, sulfur over here. So it is 2x, and here it is going to be 8 into minus 2 equal to 0. So students, here it is going to be what? It is plus 2 plus 2x, and here it is going to be minus 16. So students, it will become what? It will become 2x minus 14. Yes, so what you will be getting? Your x is going to be what? It is going to be plus 7. Yes, this is which oxidation number? This is your average oxidation number. So average oxidation number, and this is sulfur. For sulfur you will say maximum oxidation number is going to be what? It is going to be plus 6. Okay, for sulfur maximum oxidation number is plus 6. So students, what you will say? You will say if 2 central atoms are present, you will simply subtract maximum oxidation number from the average oxidation number. So average oxidation number is 7. Okay, and maximum oxidation number is 6. Okay, you don't have to divide it with 2. So answer is going to be 1. So here there is only 1 peroxy linkage. There is what? There is only 1 peroxy linkage. If we draw the structure, it is going to be somewhat like this. See, here there is sulfur. Here there is one oxygen. Here there is one oxygen. Here you write it as OH. Here you will be putting O, here there is O, here there is double bond O, and here you will be writing it as what? OH. So here students, it is what? It is H2, S2, and then it is going to be O8. 1, 2, 3, 4, 5, 6, 7, 8. Yes, here you can make out that there is only what? There is only one peroxy linkage, students. So students, the trick to find out the number of peroxy linkage. If there is only one central atom, average minus maximum oxidation number divided by 2, you will get the number of peroxy linkage without knowing the structure. Even if you don't know the structure, you can find out the number of peroxy linkage. And if there are two central atoms, you have to simply subtract maximum oxidation number from the average and you will be getting the number of peroxy linkage. One more example we will take. So students, here the example is going to be like this. Suppose we will say it is K3CrO8. Yes, it is going to be K3CrO8. For this we will say 3 into plus 1. Here again we will write it as X. Here 2 into minus 2 is going to be 0. So here it is plus 3 plus X. Here it is going to be plus, it is minus 16 equal to 0. So X is going to be what? It is going to be 13. Okay, so here the X is going to be what? It is going to be plus 13, students. What is this number? This is your average oxidation number. And students, remember, here there is only one central atom. So you have to find out maximum also. Maximum oxidation number of chromium is going to be plus 6. So students, what you will be doing, you will be saying it is average minus maximum PL, okay, to find out the number of PL, number of peroxy linkage, okay, number of peroxy linkage. So it is average is 13. Okay, average oxidation number is going to be what? It is going to be 13 minus 6, and you will divide it with what? 2. So it will become what? It will become around 7 by 2. So it will be 3.5, which is very close to 4, and you know there are 4 peroxy linkage in this particular structure. And if I draw the structure, see, it is going to be Cr. Okay, here there is one O. See, this is 1 peroxy. This is 2 peroxy, this is 3 peroxy, okay, this is going to be the 4th peroxy, and here there is going to be what? It is going to be potassium, potassium, potassium. So 1 peroxy, 2 peroxy, 3 peroxy, and here there is going to be what? It is going to be 4 peroxy linkage is present. Here the answer which we got, it was 3.5. So we have rounded off it to the nearest number, which is going to be the next nearest number, which is what? 4. Okay, one more we will do, and see, here it is H2. Yes, it is H2SO5. This is which acid? This is going to be your Cargos acid. Yes, you write it as Cargos acid. That is going to be peroxomonosulfuric acid. Yes, cargo acid, peroxomonosulfuric acid. You have to find out. See, there is only one central atom. So what you will do? You will say 2 into plus 1 plus X, 5 into minus 2 is equal to 0. So here it is going to become what? Plus 2. Here it will be X. Here it is minus this 10, and here it will be 0. So X is going to become what? It will become plus 8. What is this number? This is your average oxidation number. Yes, this is your average oxidation number. And what is the maximum oxidation number of sulfur? It is going to be what? It is going to be plus 6. So what formula you will apply? You will say it is average minus maximum divided by 2, because there is only one central atom. So what you will say? You will say it is going to be 2 by 2. So which is going to be 1. And what if we draw the structure? It is going to be H. Here it is O. Here there is one O. See, double bond O, double bond O. Here it is OOH. See, this is one peroxy linkage. H2SO5. There is only one peroxy linkage. So students, in this part we have learned the tricks to find out number of peroxy linkage when there is one central atom and when there are two central atom. Hope students you have understood with the part. Thank you for watching the video.